My name is Itay Niv, and I'm excited to talk to you about my thesis project today. I'm particularly excited to be here as both my father and my brother completed their engineering studies here at the Technion. My project is called Let's Read a Story, and it was completed in the Interactive Telecommunications Program, ITP, at the Tisch School of Art in New York University this year. Some people call it the School of the Recently Possible. Let's Read a Story is, in short, an exploration on how computers and technology can turn story time into a conversation between parents, children, and a computer. Before I show it to you, I want to talk a little bit about the reason I chose to explore this specific topic to begin with. Earlier this year, my partner and I discovered the exciting news that we were expecting our first child. When the moment came to think about what I wanted to work on for this project, the arrival of my son was a great inspiration on the thought process. I understood pretty fast that I want to research and build something with technology that would allow me to connect with him. As we started to read text about child development and parenthood, I came across this quote by the poet Friedrich Schiller. Deeper meaning resides in the fairy tales told to me in my childhood than the truth that is taught by life. This quote got me thinking about my childhood and the memories of books my mother, father, and brothers had read to me. Like many others, as a child, books and movies were my entire world. From them, I learned what friendship meant, the values of family, love, and at later stage, it is from animated movies I learned English. That got me thinking, what has changed in the last 30 years since I was a child? Quite a lot. The rising popularity of smart devices and speakers has increased exponentially in recent years. Next year, on average, each American household will have a smart device like Amazon Alexa or Google Home. Kids are talking to technology, and technology is starting to talk back. So, does this mean we can start talking to books? This was the seed of thought behind this project. And so I'd like to show you what I worked on in the last couple of months with Let's Read a Story. But wait, before we get ahead of ourselves, let's start by asking, what is a story? According to Freytag, the 19th century playwright, the dramatic structure is divided into 5 parts: exposition, rising action, falling action, climax, and denouement, the story's catharsis. But as we all know, a story can be something completely different sometimes.
Once upon a time, there was a robot girl, and she was kind of shy, so she goes in her robot collection, and she just goes in the city, the robot city, where there was all the robots, and the end.
The end. So, for me, a good children's book is much more than just text. It's also illustrations and sometimes music that accompanies it. One of my favorite books growing up was Peter and the Wolf by Sergei Prokofiev. Peter and the Wolf had an orchestral soundtrack. Each character in the book had its own theme music that was played by a different instrument. The illustrations were amazing, too. So as I planned the project, I knew I wanted to work with text from children's books to create the experience. And I wanted the project to facilitate conversation and imaginative thinking, to incorporate various components like illustrations and sound and characters, etc., and for it to be as accessible as possible. Since the main part of the project is text generation, it was clear to me that the avenues which I wanted to research and explore were first and foremost language models. And I had to choose a data set to work with. I ultimately chose to focus and analyze Aesop fables. I was drawn to the Aesop fables text because of its concise yet rich storylines, the use of animal archetypes as metaphors, and the strong morals embedded in each story. After research with various language models, I came across the idea of word vectors. These models are types of neural networks that are trained to reconstruct linguistic context of words and produce word embeddings. Word vectors represent words as multi-dimensional floating point numbers where semantically similar words are mapped to proximate points in geometric space. The beauty representing words as vectors is that they lend themselves to mathematical operators. For example, we can add and subtract vectors, treat them like numbers. With the canonical example here is showing that by using word vectors, we can say that woman, queen to woman is like king to man. Using a machine learning model called Universal Sentence Encoder that analyzes and encodes sentences and paragraphs into high-dimensional vectors, I analyzed all the sentences derived from the corpus. This yields a file I call the embedding map, containing sentence embedding for each sentence in a high-dimensional space. We can then visualize it in 2 dimensions like this. In this map, we can see that word-oriented sentences are clustered next to each other. The first time I generated a new narrative out of this map, I wrote a computer script that picks a random sentence from the analyzed Aesop fables text and gives back the 10 closest sentences, and this was the result I got. They cried. He cried. Ho, what have we here? They cried. They had done me no harm. It was their feast, they thought. It was now the ass's turn to confess. Vexed and disappointed, he began to cry. He was all alone. A passerby heard his cries and asked what had happened. And that was all the sympathy the poor mouse got. So this was exciting to me because this was a new piece of content that was generated with the algorithm and had some sort of narrative structure to it. I continued experimenting with this technique to generate new narratives. Next, I wanted to see how an original story progression might look like on the map. So for example, if we visualize the story, the swallow and the crow, this is how it would look like, and the red line signifies the story progression. So if we can visualize a story and see its progression, what if we replace the original sentences with the nearest neighbor semantically in the story? This might give us a version of that story while keeping the story's structure. So in fact, we can generate different stories based on one's story arc. Based on this method of retrieving similar stories, I began building the application, which the main focus on was to simulate a conversation. I would like to show you how the web experience for Let's Read a Story looks like. So as speech is the most natural user interface for kids and allow minimum friction between action and result, I decided to utilize Web Speech API in the web browser. Readers can input content using their voice.
Let's read a story about a cat that lived in a house.
So it understands text and then it gives an output. There was once a cat who was so watchful that a mouse hardly dared show the tip of his whiskers for fear of being eaten alive. As the story unfolds itself, readers can intervene and change the direction of the story by adding their input on how the story should progress.
The cat fell asleep on a tree and forgot about the mouse.
In an instant, the cat was up a tree, hiding among the leaves. To enrich the stories, I chose to use a recurrent neural network trained on the Quick Draw dataset, a library of millions of simple drawings created by Google. The story algorithm knows how to identify different elements in the text, and using the ML5 library, it draws them into the page while the sentence is being added. Using sentiment analysis, the story algorithm analyzes each sentence to determine whether it has a positive or negative sentiment. Each animal gets a musical phrase according to the positive or negative sentiment. After user testing the application of dozens of children, I understood the desire of kids to interact with the screen space. And so I turned the canvas into a drawing canvas, so kids can add drawings to the story. I'll jump ahead. The application went through different development stages, beginning with the simplest interface that enabled only sparse interactions, and continued to the more elaborate version you just saw now. A key part of that process was user testing with kids from different age groups. During the creation process of Let's Read a Story, I constantly found myself thinking about the ethics of this experiment. By generating content with an algorithm, am I contributing to replacing traditions and professions so precious as authors and musicians? That ironic thought disturbed me, as this was the exact opposite of the objective I had in mind. My experiment was meant to create a contemporary engagement with storytelling, not to replace it, to find new ways these mediums can be remixed and explored in new, exciting ways. The experiment is far from finished, and there's much more to learn and explore, but I did reach one firm conclusion that I'll take with me to the next steps. There's a human soul at the core of every story, and that's irreplaceable. We must always remember to create tools that would allow people to tell stories. Technology by itself is never enough. Thank you.